First of all, apologies for slight delay, technical problems, technical challenges, these are challenges. So my name's Graham Dove, and I'm faculty at NYU, New York University, and my colleague Fabio Miranda is faculty at University of Illinois, Chicago. And we are really here to introduce and talk about some work that goes back a few years, but is now leading up to really asking you guys questions, because this is talking about platforms for understanding urban data. Okay, so really throughout, anytime you're listening to this, we're showing examples, but what we're having as an ask is, do you have data sets? Do you have problems? Do you have things in your everyday life or in your work that could be solved through similar tools to the ones that we are building, and that we're building with the aim of creating platforms that make it easier to do urban computing, work with urban data, and kind of thinking about that as a service eventually. Okay, so kind of keep that in the back of your mind, and hopefully when we get to questions, it's actually you asking us, can we do these things? Okay, cool. So, so OSCUR. We're an NSF-funded project now. Really, it's building while we're going to go through examples of software, the project itself is more focused on building an infrastructure to support urban data analytics and urban computing, okay? So this is an indication, a bunch of projects that go back over 10 years now, really, and we're going to talk about, I'll briefly introduce a couple, and then Fabio is going to run through what we mean by urban data, urban computing, with some hands-on examples. Well, probably not that hands-on, actually, yeah. However it works out. But this is an indication, small set of the kind of timescale we're talking about, which is going back to 2013. And it's built on the idea of being urban computing. So the idea that you can acquire data, analyze data, work with very large data sets, combine data sets, and use that to gain insight into real world urban problems. And so kind of as an example of why this works, this kind of goes all the way back to 2012, 2013 this time? Yeah, correct. And this is the Taxi Commission, okay? Wanting to understand, tools for understanding where journeys start, where they end, what type, what number, understanding patterns of using taxis. And not us, we're way too young for this. Not us, but some of our colleagues built this tool for calculating urban taxi journeys. And if I'm really lucky, this is going to play video. Let's see what happens. No, okay, don't worry. So I'll go back to that. Really, what this allowed us to do was collect origin and destination points of taxi journeys, okay, and make subset queries that allowed us to understand patterns from times of day, from particular places, from how taxis were being used in the city, okay? So keep that in mind. Really, this is all about being able to break down large data sets to understand patterns of things that are important to understanding urban problems. And I'll talk through a few more, so don't worry about that video. We have some that do. And then moving on to some work that followed that, thinking we were approached by a set of architects this time to look at shadow, to look at the impact of building on streetscapes, on public spaces. So when you put something new into a space, how is that going to impact the shadow? How is that going to impact what it feels like to live there and to work there? So basically, how can we understand this pattern? I mean, New York, we all know shadow. There's places where you barely see the light of day, okay? Okay, so this is the problem. We were trying to understand what we can do. And so I'm going to run this. This is video. We built a tool that enables us to ask what-if questions, okay? Enables, in this case, shows you the tool is pretty old. These buildings actually exist now. The big, tall, skinny buildings on the south side of Central Park. This was looking at what might happen once those had been built, okay? And we can also look at what happens when you take out buildings from a space. How does that improve the shadow? How does that change the landscape as you move through, as you make planning decisions for choosing what to build and where? Okay, kind of key challenges for urban situations. And not only that, we did some work for this with the New York Times a few years ago now. You may have seen this. That basically allows us to, and I'll run the film here again, hopefully that will play. Yep, that basically allows us to look at the impact of buildings, the amount of shadow that is cast in particular places, differing in winter, spring and fall, or over summer. Okay, a little hard to see there, but basically that's what's showing how much of the streetscape is covered by shadow at those different points of time in the year. So this is thinking about really large-scale data, but micro-scale problems, okay? Thinking about how you can do something that impacts you at a particular lived experience of being at a certain point in time in the city, how we can think about that from a large, big data kind of perspective. And we've continued to do this in other cities. It's obviously not just New York that this impacts. So we have maps for Chicago, Washington, LA, and Boston as well. Okay. And then similar kind of thing. Okay, we're thinking here, right, about large-scale data sets, how they help us to understand street-level experiences, street-level understanding. So it's mixing that kind of big data approach with that kind of Jane Jacobs approach, okay? So we're thinking about how does it feel? How can we understand different aspects of the city using available data? So this tool was built on dashcam data, okay? So the kind of stuff that gets collected by cars as they're driving around. And one of the things that it has is it gets temporally dense picture of the city. So you're going past the same places again and again and again and again. So we can look at what it looks like as the city changes. So this is an example of how the same place changed over the period of 1 year, for example, okay? So we can look at kind of all kinds of challenges. And one of the things we were doing here, we were working with occupational therapists. And the reason we were working with occupational therapists is because the way that the city is lived in, the way that people are able to use aspects of the built environment, so for example, curb cuts, isn't fixed, okay? It is not, curb cut there, great, curb cut fixed, every problem is the same. Well, what happens in winter? What happens when it rains? How does that change the accessibility of this particular place? So we can see the kind of same spot in the city. What happens to that curb cut when it snows? What happens when it gets really slushy? Okay, I do this all the time. I'm sure everybody else has done it. You're getting to the end, you get into the street, you walk along, you think, okay, I can keep going. Next thing, 8 inches of slush up your legs, okay? All right? This, to me, it impacts me. It gives me a wet ankle. But, it doesn't stop my ability to traverse the city. So if you're older, if you're less able, then that can have a real impact on your ability to get out and around. So this is why we were working with occupational therapists to take this big data approach to different places in the city, but to have a street-level understanding of it. And then the other thing, this is video. The other thing it allows us to do, because it is that micro scale and large scale at the same time, it allows us to look for similarities in different points of the city. So using an image search, we can find where buildings are geographically distant, but kind of stylistically similar. So I'm going to hand over to my colleague Fabio, and while he runs through examples of how the platform works, how the system works, and talks a little bit more about the kind of overarching methods, maybe some more of the history of things as well, if we're lucky, then think about these kind of like 3 questions. This is really what we want you to take away. So are there problems that you see in your work or in your non-work lives that might be addressed through this kind of model of urban computing, where we use large-scale data sets to look at small-scale problems, okay? Are there data sets that might help you better understand things if they were connected? So one of the things we're looking to do is build tools that connect data sets, okay, that allow us to ask more complex questions and repeatable questions. One of the issues now is that most tools are built for one-off analysis, and this is the history of the stuff we've done, typically built for one-off analysis. But how can we build these tools so that they become platforms, so that they become urban computing or urban data analysis as a service? And then are there opportunities for anyone who is involved in policy? Are there opportunities for us to think about more kind of like data-informed policies that this kind of computing, this kind of data analysis might support? So bear that in mind. When we come back to you asking us questions, remember that we also want to ask you questions too.
So, have this slide here, which gives you more or less an overview of what Graham just mentioned. Those are 4 tools that Graham covered, and as he said, all of these tools were built in isolation as bespoke tools, right? And even though they were useful in their own way, it took us 30,000 lines of C++ code, 50,000 lines of C++ code, 30,000 lines of C++ code, which is not scalable if we want to deploy tools such as this in other locations, and especially if you don't have access to a computer scientist or to a PhD student. So the main drive behind OSCUR was, how can we take all of these functionalities that we have been building over the years and package them in a way that makes it accessible to users outside of computer science, outside of a lab such as the one that we were in when we developed this. And so for the next few minutes, I'm going to talk about 2 outcomes of this OSCUR project that try to move towards this idea of making sure that the functionalities that we have developed are accessible to people outside of computer science, and accessible accessible not to users, but accessible in a way that anyone can open these tools and make the modifications necessary in order to adapt those tools to their own use cases and to their own workflows. And the first outcome of this OSCUR project was this tool framework that we call the Urban Toolkit, which is grounded in this idea of visualization grammar. The motivation behind that was, how can we facilitate the construction of these tools so that instead of writing 50,000, 60,000 lines of low-level code, you're only interacting with some high-level description of the system. And the goal was to, how can we support such an approach through an accessible, flexible, extensible, reproducible, and scalable way so that it can work for domains and users beyond computer science and beyond the domains that we were originally thinking about. The approach that we took was based on this idea of visualization grammar. And when you are creating a visualization, you can think of this spectrum in which you have tools that are very easy to learn, such as Tableau. And on the other end of this spectrum, you have tools and frameworks that are very difficult to learn, such as JavaScript and D3. And in the midpoint of this spectrum, you have libraries such as Vega Lite and Vega that abstract some of the functionalities through this high-level grammar, high-level description of a particular problem, of a particular domain. And these visualization grammars have been applied to several domains, from biology to GIS. And what we wanted to accomplish was, well, what does it take to build a visualization grammar that's specific to the urban domain? And that's where UTK, the Urban Toolkit, came from. So how can we abstract everything that you're seeing on the left side, the thousands upon thousands of lines of C++, Java, low-level Python code, into something that's much more manageable for a user? So instead of having access to a team of computer scientists, students, you can interact with a high-level description of the system. And that's what we did with the Urban Toolkit, which was to abstract these low-level functionalities, provide easy access to data analytics, and do this in this self-contained and shareable JSON file. So one of the major problems that we had when developing the tools that Graham mentioned was to share these outcomes with domain experts, right? With the urban experts that we were collaborating with. It was always a heavy task to share executable files, to share binary files with them. So here with the Urban Toolkit, we wanted to make sure that we had something that was easily shareable. And we take this approach in which everything is described in a self-contained JSON file. So, for instance, in this example, you're seeing a 3D visualization on the right side. Oh, sorry. So the Urban Toolkit not only handles the visualization side of things, but it also provides a series of API functions to load OpenStreetMap data, parse OpenStreetMap data, perform certain simulations such as sunlight access. And all of this data, all of these functionalities are provided to you either through a Python API or through a JSON file. So what you're seeing here is a user specifying what the visualization should look like on the left side, and on the right side, the outcome of that JSON specification. So the specification is being interpreted by the UTK engine, and on the right side, you see the result of that interpretation by the UTK engine. And the main point that I want to make here is that something that you see on the right side would take 50,000+ lines of code. And we were able to abstract certain low-level functionalities through this urban-specific visualization grammar that you see on the left side. And on our website, we have a handful of examples of constructing different visualizations through the specification of the components of this visualization. So the main point that I want to get across here is that everything that you're seeing on the right side is being generated by what you see on the left side. from the data, from the spatial joins, from attaching a particular set of data sets to the visualization, everything is being driven by what you see on the left side. So you don't have to worry about implementing, writing low-level C++, Python, Java code. You can simply interact with a high-level description of your system. And this is a more complex example in which we were interested in analyzing sunlight access on the facade of buildings. So the visualization that you see on the right side, the buildings are being painted with shades that go from red to blue. And the areas that go towards red are the areas that have less amount of sunlight access. And everything that you see on the right side is being generated by this specification that you see on the left side. So while previously using the tool that Graham mentioned, you would take 50, 100,000 lines of C++ code, what you see on the right side is being created with just maybe 200-300 lines of JSON specification. So the point of a framework, a tool such as UTK, is to abstract some of the functionalities so that anyone, even without programming experience in C, C++, Java, can create something like you see on the right side. And that work was published back in 2023. And afterwards, we were still unsure on how to accomplish certain use cases, right? Even though we were able to abstract certain functionalities into a visualization grammar, it wouldn't be accurate to say that I can accomplish every single use case that an urban expert might need to accomplish. So the functionalities provided by UTK are still somewhat restricted to what we can accomplish through a JSON visualization grammar. So then we took a step forward in the creation of this other framework called Curio, that is a extension of UTK, but now uses another interface that allows users to create data flows, urban-specific data flows. And basically, what Curio allows you to do is to establish every single step, all the way from data collection to data cleaning to data modeling and data visualization in this self-contained environment. So every single step that's usually performed by an urban expert, an urban scientist, from data collection all the way to data visualization is within the scope of Curio. And while UTK was primarily worried about the two last steps of this workflow, Curio is an end-to-end framework that allows you to both collect data all the way to the visualization of data within the same environment. And we're going to talk about a few examples in just a little bit. But when designing this framework, we were primarily interested in achieving three design goals. We wanted something that allowed for collaborative visual analytics. So if you're collaborating either with a computer scientist or with an urban expert, a policymaker, how can we have a canvas that both of you can work together to tackle a meaningful problem? And we wanted to do this in a flexible and modular way. So instead of having this monolithic system that's very hard to tweak, to change, to make adaptations to another scenario or to another city, how can we build something that's flexible and modular? And ultimately, we wanted to support reproducibility and the provenance of these modules. So instead of one thing that is particularly challenging is if you're using Jupyter Notebook, for instance, keeping track of all of the different versions that you might generate through the process of urban analysis. And one of the design features that Curio provides is a way for you to keep track of all of the changes, all of the modifications that you make throughout the urban analysis process. So these are the three main design goals that we wanted to achieve in the creation of this framework called Curio. And as I mentioned, Curio supports multiple users through this abstraction of data flow. And one of the nice things about Curio is that it gives you this access to multiple levels of abstraction. So let's say that you are a person that's familiar with Python coding. You can have access to Python coding through the nodes of Curio. But if you are someone that's not particularly an expert in programming, you can still have access to some of the functionalities provided by Curio through the grammar that I just mentioned a few minutes ago. And if you're just an end user that's not interested in working at the code level or at the grammar level, Curio also provides you with a set of UI widgets that allows you to tweak some of the parameters of your analysis in a much easier way. And ultimately, the combination of all of these abstraction levels will lead to a visualization node that you can share with collaborators, with users that you might be interested in working with. And at the core of Curio is this idea of templates. So what you're seeing here is the user creating a new data loading template and adding some Python code to that template. And then the user is saving this template as a new node, and adding some comments, descriptions to that particular node. And the most interesting part of that is that this can be easily shared with another person. So the use case of that, you can think of, if you're programming some Jupyter Notebook and you have this very complex cell that it does some sort of data modeling, data simulation. While in a Jupyter Notebook, you are constrained to copy-paste that particular cell and share with someone else. In Curio, you can save this as templates and then share those templates with collaborators. And the very nice thing about this is that if your collaborator makes some changes to your code, those changes will be tracked by the provenance system that we have underneath this Curio framework. And here's what Curio looks like in action. So basically, in this video, what we are seeing is a user creating several nodes. Each one of those nodes is performing a particular task, such as data loading, data cleaning, data visualization, and they are all connected through these edges that will represent the flow of data from left to right. So you might think that a use case for this is you're interested in some NYC open data, Chicago open data, Seattle open data. You might have nodes that were specifically designed to load NYC open data, nodes that were specifically designed to clean NYC open data, and then you compose this data flow until the generation of your visualization. And one key feature is that everything that you perform is being, we're keeping track of every single change that you make. So let's say that you have this very complex data analytics pipeline, data flow, and there is some change that you need to do in the third or fourth layer of your data analytics pipeline. You can easily make those changes and then rerun the pipeline. And in the event that you might want to revert to an old version, you can simply keep track of that using the provenance system. So I'm going to go through an example of using Curio that is that will leverage data from this project called Project Sidewalk out of Seattle. Basically, the data being made available by Project Sidewalk is a crowdsourced data that contains the evaluation of street-level images by the crowdsourced users. So users are asked to evaluate accessibility problems, sidewalk problems, and then Project Sidewalk collects this data and makes this data available as a set of CSV files. And the example that I'm going to show to you is creating a set of visualizations leveraging this Project Sidewalk data set. So what you see here is a white canvas, an empty canvas, where the user will compose the pipeline that he or she is interested in. From the initial stages, data loading, data cleaning, all the way to the generation of the visualizations. And everything is self-contained in this canvas. And a very useful aspect of this is that you can save this canvas and share with someone else. So you don't have to share, some Jupyter notebooks, Python code, or executables. You can simply share a description of this canvas, and someone else can rerun your analysis. So the user is now loading a set of 3 data sets that come from the Project Sidewalk set of CSV files. And the user will now create a set of nodes to load this data. So this is what the node looks like in Curio. This node is basically loading Project Sidewalk CSV data, and then the user is now going to add another node, the one that you see on the right side, to perform some data cleaning on that raw node. In that specific case, the user is leveraging a already built template to remove columns that he or she might not be interested in. So they are just filtering for the data columns that they are interested in. And on the rightmost side, we are computing a statistical analysis from that particular data. We're computing a measurement of uncertainty for that using that particular data set. In the last step of this first part will be the user creating a data pool that will allow them to investigate some of the components of the data. So what you see on the rightmost node is just a table showing you every single column after the data loading, after the data cleaning, and after the data analysis / modeling. Another user is going to perform a similar set of steps, but now loading the spatial boundaries of Seattle. So the user just created a node to load a GeoJSON file with the description of neighborhoods in Seattle, is performing a data cleaning step to remove all of the areas outside of Seattle. And then the last step that the user is going to perform is a comparison between these two set of data sets that they just loaded. Let me just go ahead just a little bit here. So what the user is doing now is he or she is going to create a visualization node that is going to take this particular table and is going to automatically generate a spatial visualization with the distribution of accessibility problems in Seattle. So what you see on the rightmost node is is a map of Seattle with shades of red representing places in Seattle where you have a higher occurrence of accessibility problems. And the other nice thing about using Query is that you can concatenate different visualizations. So now the user added a Vega Lite visualization, just a simple bar chart, and the user is going to now connect the map visualization with the Vega Lite visualization. So the bar chart is showing you the uncertainty of the crowdsourced data, and the user can interact with the bar chart and see what is the area in Seattle that he or she is interacting with. So the user is going to create a edge between the relevant nodes, the edge being in red, and what the user is telling the system to do is to propagate interactions between the map and the bar chart. I'm going to speed up this just a little bit. So basically what the user is doing now is creating another map with another attribute of the data. And the one thing that I want to highlight here is that you might want to share this analysis with someone else. And one of the nice features from Curio is that you can enable this dashboard mode in which you will hide every single computation, every single node, every single edge, and the only thing that will remain in the canvas will be the visualizations that you selected in order to share those results. So the user is pinning certain nodes. He or she is going to click on the dashboard node, and every single node that wasn't highlighted is being hidden, and the only thing that the user is now seeing is the set of visualizations that they created after setting up the data pipeline. UrbanTK, as well as UrbanTK, which is the first one, the visualization grammar that I just showed you, as well as Curio is publicly available on that website with a set of examples, hands-on examples, tutorials, and guides that you're more than welcome to try for yourself. And lastly, I'll leave with the questions and suggestions.
You're going to have to answer the questions because I can't answer any of those technical questions. So we wanted to leave some time for kind of two key parts. So any questions you have of the stuff that we've just been running through, well, any suggestions you have, any problems you have, any things to think about, anything that can we support? Yeah. Let's start at the back with the...
Just a problem and potential use case. I recently worked on a project for a graduate degree that was basically trying to deliver a dashboard that would speak to the suitability of different neighborhoods for adding more housing. Sort of speak to the housing crisis in New York City. And one of the challenges was variance in geographic boundaries. So different data sets, as I'm sure you know, are defined at like different levels of geography, right? It could be census block or census tract, it could be school district, it could be lots of different kind of boundaries, and that was one of the challenges of the project, like knowing what school district is this community district in, given that there would be 2 or 3 overlapping districts. So I was just curious if your toolkit helps with that. And then another problem that I wanted to share was just the recency of the data and like building a pipeline that updates data sets on the fly, because some of these are updated every quarter, 6 months, year, that kind of thing.
So I'm going to pass this over to...
That's a great point. On the geographical boundaries, right? We haven't tackled that yet, but one of the goals is making the data wrangling, cleaning, and joining as easy as possible, right? So in the short term, one of the things that we will focus ourselves is making sure that we have the tools, the APIs, and functionalities to make the data wrangling as easy as possible. And that was one of the things that we wrote in the proposal, right? Because one of the largest sources of effort is, tags of effort is, doing the wrangling and cleaning work versus the analysis, right? And we want to make sure that we have functionalities that are built in order to bring down the amount of effort that you need to put in. It's not in place right now, but it's certainly a very pressing use case.
And you can think of that from the perspective of having like a shared point. Once you set this up once for a city, this is kind of the thinking of it at a platform level and as a service level. It's a plugin. It becomes a plugin to your pipeline of working it through, and in that geographical sense, it may be as low as a set of coordinates, and what's the whole kind of city coordinate map, and how does it fit into different, I guess you'd kind of call them political constructs, really, at that point of view. So it's certainly something we're thinking about, and certainly something that once you do it, it becomes available. So yeah.
If such a resource did exist for New York City in a cloud database or something, I could say it definitely be useful to me and people that.
Yeah.
That's well, I'm not sure when that will happen, but that's certainly one of the goals, which is make this as easily accessible as possible, right? And doing this over the cloud is one of the goals.
And there was a second part to your question as well.
Oh no, that
That's the
update thing.
Okay,
yeah.
Cool, awesome. Sorry, one last minute, and then we'll come to yeah, cool.
Hi, my name is Jeffrey. I have kind of like 2 questions. One is more about the data loading and cleaning. I was a little confused as to what exactly the data is that you're passing into your data pipeline and how it's being cleaned. The second part is like you generate like a model of the map after this, right after that data is supposed to be passed. Are there any, and then you have like the analytical process as well. Is there anything to like generate like maybe a list of analysis or like impacts on the actual region that you can model? Do you want to build a building somewhere like where that?
So the second point, no. But I would say that we are providing the framework, right? In the analytical boxes, components, and nodes, that's up to the expert that will use the system. So we are really providing the canvas that anyone can fill that canvas in however they want, but specific use cases that will be driven by the expert themselves. And the first question was?
About the data loading.
Yeah. So
what kind of data?
Yeah. So right now it supports CSV data frames and geo data frames, as well as we have connections with Socrate as well. we will keep supporting this, but we want to make sure that it's we have as many entry points to different loading formats and types of access that we'll keep adding them.
I guess specifically, what are the parameters that you are feeding into the model?
It's just so depends of the model, right? As I mentioned in your second question, depends of the model that I showed you one sunlight access model. There was another one which was modeling accessibility problems, right? But those were, boxes that you can put in the canvas and then analyze the output of these boxes. We have another box which is the flooding simulation, right? So the attributes will really depend of the sort of model that you end up using in this canvas. But no.
The attributes defined, something like these are the attributes to expect the system to take.
No. So as long as you can load the data as a CSV file or data frame and geodata frame, and you have the predefined, you have the well-defined columns there, you can handle that data in the canvas from Curio.
Question up front.
Have you had actual users take this up, and you have data on their reactions, like not test users, but actual members of the public? And then also to kind of follow up with what you might have been asking is, in the examples you showed us, what were the data sets and where did they come from? Like open data? Did they come from open data? It was Pluto, it was housing data sets for New York.
So test users, we only have test users right now.
Okay.
We want to really scale this.
So most of the early projects we were showing were built with domain experts, and so from the taxi journeys, from the accessibility ones, most of these are built with domain experts. But part of one of the learnings that we had, part of the learnings we've had is moving beyond that so that it's repeatable, and then that's where we will move into. Once these are repeatable and reusable, how can we then make them accessible in that kind of general public kind of sense of way? So I guess that's kind of yes.
Yeah.
It's a yes, but I think at the moment.
And they were all built in this very small scale, right? It was always researchers collaborating with domain experts, but it was a very small group, at most 10 people, right? And as Graham said, we want to scale this. What are the key functionalities that we can provide that will allow any urban planner, architect, urban scientist to use some of these functionalities in beyond New York, beyond Chicago, beyond Seattle, right? And the second question was about the data attributes and the data format. We keep it as general as possible. So as long as you can load the data as a CSV file, the system will handle that. And the edges that you saw in this data flow, data frames being passed from one node to the other. So we didn't want to constrain ourselves to just support, Pluto or projects at Walk. We wanted to have something that's as general as possible that, with a little extra work, you can transform Pluto from to a CSV, or you can transform to a data frame, to a geodata frame. As long as your data type is either CSV, data frame, or geodata frame, you can perform the analysis using Curio.
And then you can also kind of think of it as a process of building out these modules, so that you're not having to do that every time you come into maybe a more complex kind of data or a new data type, it's like build once, use again, build once, use again. And that I think is kind of like the key thing that we want to get over and be able to make available for people to access as the project goes on, which is kind of why this notion of what are the problems you encounter, what are the things you want to solve becomes so important, because every new instance is a new part of the model that can then be opened up to people who have similar problems. Because one thing you find all the time is that people have similar problems across different projects.
Mhm.
Question at the front.
Yeah.
Probably last question as well.
Does either Urban Toolkit or Curio have an API? The motivation for the question is hooking up an LLM to have a chat interface in front of this.
That's ongoing work. The LLM is ongoing work. UTK does provide a Python API, but without any LLM attachment to that. And Curio is a canvas, right? You can use APIs inside Curio, but Curio itself doesn't offer any API to the user. It's just a canvas, not just, but it is a canvas that you can then use any API that might be of interest to you through the Curio nodes.
And that's sort of the hidden slides that
Yeah,
didn't get
the
shown,
hidden slides, yeah.
that we were talking about at the. So yeah, all of these kind of things as you think about moving forward that you hear from everywhere. Hopefully, we're trying to think about how that might fit into the whole setup moving forward. And we know that this space moves really quickly. So I guess that's it, kind of time. I want to say thank you. Our email's up there, reach out with things. We'd be super happy to hear from you. So thank you.